If you ask a room of developers what mobile device features are missing from the web, push notifications are always high on the list, and it makes sense. Push notifications are a great way to re-engage a user. Push notifications are now available on the open web through a new set of web APIs. I'm Michael, and I'm an engineer on the Push API team for Chrome, and I'm going to show you how to add push notifications to your web app. To start with, you take a normal web page and register a service worker which will handle your push messages. Then, you subscribe the user to push messages, which will register the user's device with a push service and give you some information which you store on your application server. When your server is ready to send a push message to users, you call an API on the push service to trigger a push message. The push service will then send a push message to the user's device, which will wake up your service worker and fire a push event. Then, in your event handler, you show a notification and done. The first thing we need to do is set up a project on the Google Developer Console. This is required to use push notifications with Chrome, because there isn't a standard API for push services to support yet. Hopefully, when the standard is finalized, Chrome and GCM can support it. Go to console.developers.google.com to create a new project so that you can use the GCM API. In your new project, enable Google Cloud Messaging for Android and Google Cloud Messaging for Chrome on the APIs and auth, and create a new public API access key. Make a note of the API key, as well as the project number, which you can find on the overview page in your project. To let Chrome know about your GCM project number, add a web app manifest to your site. The web app manifest is a simple JSON file that can be used to define icons and the name of your web app. For push, you need to define a GCM sender ID in your manifest, which is the project number we mentioned before. Add a link tag pointing to your manifest, so Chrome knows where to find it. You can learn more in this article. Now that the GCM bit is done, the next step is to register a service worker in your web page. Don't worry if you're new to service workers. We'll be stepping through how to use them for push shortly, but for more in-depth details, you can check Jake Archibald's talk. Call navigator.serviceworker.register, passing in the location of your service worker file. This will tie a service worker to your page. Once it's registered, you need to set up your UI. So let's imagine we have a toggle switch to enable or disable push. For browsers which don't support push, you should disable the switch by checking if Push Manager exists on the window. The next step is to subscribe the user to the push service. We do this when the user toggles the switch on by getting the service worker registration, and with the registration we call subscribe on the Push Manager. We pass in user visible only equals true because Chrome only supports push messaging with a notification. In other words, you have to show a notification when you receive a push message. When we call subscribe, the browser will show the permission prompt, so make sure it's obvious to the user why this prompt is being shown. The last thing you want to do is show a permission dialog when the user first lands on your page and you have no idea what it is. If the user gives you permission, you will receive a subscription object, and you will need to send the endpoint variable to your server, as this will be needed to send a push message. Time to send a push message. Now that you have registered with the push service and have an endpoint, you simply need to call this endpoint from your application server. Here, we'll look at a simple curl command, but you'll need to implement this in your chosen server language. For GCM, take the endpoint, parse out the subscription ID, and make a RESTful API call to the GCM endpoint, using your public API key as an authorization header, and passing in the subscription ID inside the registration IDs field. Right now, nothing's going to happen yet when you send a push message, because we don't have our service worker set up to handle the event. Let's see what a push event looks like in a service worker. For those of you who are new to service workers, you can think of them as special JavaScript files that the browser knows about and executes in the background without needing the web app to be open. The browser will start up your service worker when it receives a push message and dispatch a push event, which you can listen for with an event listener. It's inside this event listener we can display a notification. It's worth noting that when you receive a push message, you need to show a notification, otherwise Chrome will show its own notification, which you won't have any control over. To create your own notification, you need to call showNotification, passing in a title and a set of parameters to define the notification's message and icon. The notification tag is optional, but can be used to replace notifications with the same tag. One thing to really focus on is the event wait until method. You need to pass in the return promise from showNotification, as this tells the browser to keep the service worker alive until the promise is settled. And that's it. You can now send push messages and show notifications. There is one more thing. You need to allow your users to unsubscribe from push messages. To unsubscribe from push, we need to get the subscription object, which we can do by calling getSubscription on the push manager. Then call unsubscribe on the subscription object. It's at this point you'll want to remove the endpoint from your database. This has been a quick introduction into the Push API. We look forward to seeing what you will build. Please go check out these articles which cover all of this in more detail. Thanks for watching.